Welcome everyone to this section of the course on advanced Python modules. Python has several built-in modules that we haven't really fully explored yet. In this section, we will dive deeper into some useful built-in modules that already come prepackaged with Python. We'll explore their use cases, and then at the end we'll give you a fun puzzle exercise to solve that uses various modules. The modules we'll be covering in this section of the course is the collections module, the OS module and the datetime module, math and random, Python debugger, time it, and in general how to time your code. We'll also cover regular expressions and how to search for patterns in text, and then we'll also cover how to unzip and zip files with Python through built-in modules and also modules you can download. Okay, so lots of stuff to cover. Let's not waste any more time and get started. I'll see you at the next lecture. Welcome everyone to this lecture on the collections module. The collections module is built into Python when base Python, and it implements specialized container data types that are essentially alternatives to Python's built-in containers that are just general purpose. So what I mean by a container is something like a dictionary or a tuple. We've already learned how to use normal dictionaries, but Counter has specialized dictionary objects or specialized tuple-like objects. So we're going to learn about these specialized container types. You may not always need these specialized versions, but in certain use cases, you may find them useful. Let's go ahead and open up a notebook. All right, here I am in the Jupyter notebook. The first object I want to show you from the collections module is the counter class. We will import it by saying from collections, import, and then capital C, counter. Let's imagine you have a situation where you have a list and then some unique values in the list, but there's also repeats for these unique values. So I'm just going to make a bunch of 1s, a bunch of 2s, a bunch of 3s, and so on. Now let's imagine I wanted you to get a count of each unique item in this list. For example, I want you to count how many 1s are there, how many 2s are there, how many 3s are there. Well, you currently do have the skills to do this. You'd probably have to create a for loop and then have some sort of dictionary keeping track if you've already seen the number or not. And then if you've already seen it, go ahead and add +1 to the count. If you haven't seen it, create a new key and then add 1 again, etc. So that's actually quite complicated, but Counter can do this for us automatically with a single call. It's super useful in these sort of situations. Simply pass in my list into Counter, and then you get this specialized counter object that has now counted the instances for each unique item in that list. So there's 5 instances of 1, there's 4 instances of 2, and there's 7 instances of 3. And this works if there were strings as well. So let's imagine we have some A's there, and then let's say 3 10s. I'm going to say counter my list, and I can see here it counts that there's 2 A strings and then 3 instances of 10. Notice this looks very similar to a dictionary, and counter is technically a dictionary subclass that essentially just helps count hashable objects. So inside of it, elements are stored as dictionary keys, and the counts of the objects are stored as the values. So kind of this specialized dictionary where the keys are always the object, and then the value is always the count. Now this also works with strings, so I could say counter, and then pass in some sort of string. So let's say AAA, BBB, etc. Run that, and it counts the individual letters. Let's imagine I wanted to count the words in a sentence. Well, I already know this works with lists, so I could split the actual sentence. So let's create a sentence here saying how many times does each word show up in this sentence with a word, or something like that. Well, I know I can simply split this string on the white space to get a list that looks like this, which means I can then call counter on that list, and now I have a count of each word. And I see here words showed up twice. And if I wanted to, I could do something like call lowercase on everything first, then split it in case I wanted to check for capitalized versions. So finally, let's go ahead and show you some common patterns that we will encounter when using the counter object. I will say, let's say letters is equal to a string. Go ahead and put some A's in there, some B's in there, and let's put a bunch of C's and a bunch of D's. There we go. And I'm going to create my counter object. I will just call it C. Notice now I'm actually assigning counter to the result here. And so I check out C, and it tells me the counts. So notice there's 3 A's, 4 B's, 8 C's, and 11 D's. I can do C.tab. You'll notice there's a bunch of methods that look very similar to methods that we already know are available in a dictionary, like keys or values, but there's also things like most common. So most common will actually just return back the most common here in a list as a tuple. So it says D is the most common with 11 instances, C is second most common with 8, B third most common with 4, A fourth most common with 3, and it would keep going. And it's up to you to provide here a number, n, of how many you actually want returned. So let's say I wanted the 2 most common, then it would just return D and C. If I wanted the 3 most common, then it returns D, C, and B, and so on. And we've actually provided for you in the lecture notebook that goes with this. Just going to bring it in over here. If you scroll, there's a common patterns when using the counter object. It's essentially a little table here that shows you just things that are common to do, like get a list of total of all counts, reset all counts, list the unique items, convert to a set, and so on, and then the actual code you would use in order to do that. So let's go ahead and try one of these out. Let's imagine I want to list unique elements. Then all I have to do is take my counter object, which you notice looks kind of like a dictionary here, but I can actually pass this into a list, and then I essentially just get a list of all the keys, so all the unique values. Lots of different things we can do with the counter object. Obviously, it's really designed to be this workhorse for the case where you have to count unique elements. All right, we have 2 more things to show you from the collections module. The second one I want to show you is the default dictionary. So we'll say from collections, import default DICT dictionary. And what we're going to do here is show you what happens in a normal dictionary, and then we'll show you what happens with a default dictionary. I'm going to create a dictionary, quite simple, has the value A, or excuse me, the key A with the value 10. So I check out this dictionary, A to 10, no problem. And if I call the key A, it returns back 10, as expected. But in a normal Python dictionary, let's imagine I call the wrong key. So notice wrong, definitely not a key yet in this dictionary. If I try that, it's going to complain saying, hey, key error, this doesn't exist within this dictionary. In certain situations, especially when you're doing something like a for loop that you want to quickly add in keys that are not already present in your dictionary for whatever particular reason, you can use a default dictionary. And what a default dictionary does, the way it gets its name, default dictionary, is it will assign a default value if there's an instance where a key error would have occurred. So essentially, if you try to ask for a key that isn't present in a default dictionary, it will assign it with some default value. Let me show you how you can create this default dictionary. And the way we do this is by saying whatever your dictionary is going to be, so we'll call it D again. In this case, we call it default, DICT, for default dictionary, and we have to choose what the actual default value will be. So instead of returning a key error, it'll assign it our default value. And we can do this through the use of a lambda expression. So we'll simply say lambda, colon, and then whatever you want the default value to be. For instance, let's say I want all the default values to be 0. So it still behaves like a normal dictionary under normal circumstances, where I can assign some key. So let's say this is a correct key. I'll assign it the value 100, and if I call it again, it turns back 100. But now, let's put in a key that we know is not currently present. So in a normal dictionary, this would result in a key error. But maybe you have a situation where you want your script to keep running and you want to assign some default value, like 0. So when we run this, notice we don't get that error anymore. Instead, it's automatically assigned it this default value. And now when I check out the dictionary, I see it's a default dictionary. It reports back that it has this lambda function here. That's what this is, or a lambda expression. And then we have the wrong key, 0, correct, 100. So hopefully you can see the various use cases for a default dictionary. Perhaps you're trying to assign values to a dictionary, but you don't know if everyone's present or not. So maybe you just have a default value of 0 for them if you encounter them and don't have them in the dictionary yet. Okay, so that's the default dictionary. The last specialized container object that I want to show you from the collections module is called the named tuple. So similar to the way a default dictionary tries to improve on just a standard dictionary by getting rid of this key error with a default value, the named tuple tries to expand on a normal tuple object by actually having named indices. So let me show you what I mean by that. Let's create a standard tuple. We'll say my tuple, and it's just 10, 20, 30. So this is a very small tuple, which means if I wanted to grab, let's say 10, I know I can see it's at index 0, and there we have 10 returned to us. So I just need to look up the index, pass it in, and then there's 10. Now, in certain situations, you may have a very large tuple, or you may not remember which value is at which index. So the named tuple is going to have not just a numeric connection to the values, but it will also have essentially a named index for that value. So instead of just calling it by 0, we could call it by some sort of string code. Let me show you how we can construct a named tuple. It actually kind of looks a lot like a class. So we'll say from collections import named tuple, and let's construct our named tuple, which is almost like constructing a new object using object-oriented programming, or OOP. So we'll say dog, note there's no parentheses here, is equal to named tuple. And there's two main parameters, which is the type name, what type this will be reported as, and then the field names passed in as a list. So let's go ahead and say that the type is going to be a dog, and then a dog will have an age, a breed, and a name, almost like attributes in a class call. And now I can create instances of a dog object. So note dog here, and what I'm going to do is create a dog called Sammy, and then I'm going to say that Sammy is 5 years old, the breed is a husky, and then the name is just Sam. So we have this variable Sammy. If we check the type of it, notice it reports back that it's type dog. It doesn't report back that it's a named tuple. So if I take a look at Sammy, notice it looks kind of like a mix between an object you would have created with object-oriented programming and a tuple itself. So essentially, it's kind of like this tuple here where you had 10, 20, 30, but notice now there's essentially an association with each value. So it's age for 5, husky for breed, name for Sam, which means I can call these by saying Sammy dot age as if they were just attributes on this. So then I can call for the breed, and then I can call for the name. Now notice if I say Sammy at index 0, I get back 5, which was the same thing as calling Sammy.age. So you can imagine for very large tuples or tuples where you can't quite remember what value is at which index, it might be useful to be able to access them both by calling an index position, such as 0, or by calling it as if it was an attribute, asking for the age. Alright, so that's it for this lecture. You can check out the full documentation online on the collections module. These aren't things you're going to use for every single Python script you ever write. However, there may be certain situations where these can really help you and are more of a convenience for you. So you can check out the full docs online, and I will see you at the next lecture. Welcome back, everyone. In this lecture, we're going to be focusing on two built-in modules which relate to opening and reading files and folders on your computer. And that is the Shell Utilities module and the OS module. So Shuttle or OS. Essentially, we already know how to open an individual file with Python. We saw that at the very beginning of the course. But we still don't know how to do a few things, such as, what if we have to open every file in a directory and read and write to it? How would we actually find those correct directories and loop through them, especially if there were subfolders within subfolders? Also, what if we actually wanted to move files around on our own computer? Python's OS module and Shell Utilities module allow us to easily navigate files and directories on the computer and then perform actions on them, such as moving them or deleting them. Let's go ahead and explore these modules and get started. Okay, here I am underneath Advanced Python Modules folder. I wanted to note here that the lecture notebook that corresponds with what we will be showing here is called Opening and Reading Files Folders. So keep in mind it's not called something like OS module and shell utilities. So right now the lecture notebook is this one, opening and reading files and folders. And I would recommend that you follow along with a notebook in the same location as me, which is under Advanced Python Modules, since we're going to be doing things like listing directory structure. And if you want to see similar results, it should be in the same location as where I am. So I've gone ahead and created a new untitled notebook, which is this right here. All right, so again, if you're doing this in another directory on your computer, keep in mind the results you see may be slightly different than ours, but the actual logic should still be the same. To discuss opening and reading files, let's quickly review an understanding of file paths. If you're in Jupyter, you can type pwd, hit enter or shift enter, run this cell, and it will report back your current working directory, which is right now here under Complete Python 3 Bootcamp and then Advanced Python Modules. The second most important thing to note here is it actually reports back the syntax structure for writing a file path for whatever your operating system happens to be. In my case, I'm using Windows, so it separates folders or directories with this double backslash. And that sort of formatting is important later on, so keep that in mind. If you're using something like Linux or Mac OS, it's probably going to show you a /, but it should show you the correct format. Okay, so I understand now where my notebook is located. What I want to do before we get started is create a practice file. So I actually already know how to create a practice file or any text file, write to it, and close it. Now what I mean by that is early on in the course, we covered doing something like this, where I will open up practice.txt file, and since this actually doesn't exist yet, it will actually be creating a text file, and I want to write to it. So I will have my mode be write plus, and let's go ahead and write something to this. This is a test string, and then I will close the file. You can do this with a with statement if you prefer. So if you run this, basically what happens is it's going to open up practice.txt file and overwrite this is a test string on it and close it off. So now if I take a look at Advanced Python Modules, you should be able to scroll somewhere here and see practice.txt file, which if you click on it and open it, it says this is a test string. Perfect. Okay, so we'll be working with that text file later on. But let's come back to our notebook and first discuss how to use the OS module. So the OS module is really useful because it allows you to do things like get the current working directory or list all the files in a directory, and these commands work across all operating systems. So I simply say import OS, and I can say os.get cwd current working directory, open and close parentheses, and it reports back the current working directory. So pwd right here, this is kind of a special command within Jupyter. It also works technically at your command line if you're running something on Mac OS or a Linux-based system. But this os.getcwd, that will work within any Python script. It'll report back your current working directory. And let's imagine I wanted to list items in a directory. If I say os.listdir, it will list everything in my current directory. So here I can see all the notebooks I had, I can see some folders, the text file, as well as the practice.txt file, and my current notebook. Now by default, if you just say list dir, it's going to list all the items in the current working directory. What I could do is list items in another directory. So for example, if I wanted to, for instance, figure out what are all the files and folders I have under users, I can run that, and now it's going to list everything underneath users. So I can see all users, default, my profile, public, etc. So list directory essentially just takes the argument of path, you pass it in, and it lists all the items there. This will be very useful if you wanted to maybe have a for loop to open up all the files in a directory. And we'll see later on how we can do that in an even more robust manner through os.walk. So now we know how to get the current working directory, and again this works on any operating system or any Python script, and we know how to list all the items in any directory. Now let's go ahead and show you how you can move files around, which is something we actually don't know how to do yet. What I'm going to do is I'm going to import the shell utilities module, which is just shutil, and it can be used to move files in different directions, or in different locations I should say. So right now I have my practice.txt file located right here under Advanced Python Modules. Let's go ahead and show you how you can move it. You simply call shell utilities.move, And it essentially just takes two main parameters, which is src, the source, and dst, the destination. So it's very similar to the Unix mv command. If you're comfortable with the Linux command line, this should feel familiar. Essentially what we're saying is take this source and move it to this destination. So let's go ahead and grab that practice.txt file. And then the next thing I need to do is tell Python where I want to move this file to. I need to choose somewhere where I actually have permission to move it to. So if you're running this on a work computer or work network where you don't have full admin permissions, you may actually encounter an error here. So make sure you have permissions on your computer to do this. I know that I'll have permissions in my own user folder, so let's go ahead and do that. Going to copy and paste this path. Let's type that in, move that, and now basically it reports back that this practice.txt file is now located underneath my username. And if I take a look back at my folder, Advanced Python Modules, and scroll down, notice that practice text file is no longer there. And if I were to search on my computer underneath my username, I would find that practice.txt file there. And I can actually confirm this by just saying os.list directory. Let's go ahead and list everything that's under my username. Whoops. Run that. And I should somewhere here be able to see that practice.txt file. So if you keep scrolling down, eventually, let's make sure it's in alphabetical order. Here it is, practice.txt file. Perfect. So I was able to take a file and programmatically move it somewhere else on my computer. Now something to keep in mind is OS has a lot of functionality available on it. So as you get more advanced, you may find yourself wanting to do more things with it. You can say os.tab, and you'll notice that it has a huge list of things it can do. For the most part, we're just going to be teaching you the basics here, how to move things around, how to open things, list directories, and how to remove things. So there's three ways to actually delete a file, and I talk about this within the lecture notebook. So I'm just going to quickly bring that over to discuss it. So I'm going to scroll back up here, and here's the deleting file section. So we just went over moving things. And deleting files, you should note that the OS module provides three methods for deleting files. There's os.unlink path, which is going to delete a file at the path you provide. There's os.rmdir, which deletes an entire folder. However, the folder must be empty at the path you provide. So unlink is for a single file. Remove directory is to remove a folder. Folder has to be empty first, so essentially you have to unlink everything within that folder, then remove the directory. And then there's the shell utility command, which is remove tree. And this is probably the most dangerous one, which is the one I really want to talk about here. This will remove all files and folders contained in the path. This one you have to be super careful with because these methods can't actually be reversed. So they're operating essentially at the command line, which means it's not like just clicking something and dragging it to the trash, and if you made a mistake, you can take it out of the trash again. Once you delete something using remove tree, it becomes extremely difficult to try to recover the file. And you should just assume that you're not going to be able to recover it and it's a permanent removal. So keep that in mind. You should really be careful with this remove tree command and only use it when you're absolutely sure that you would have no problem deleting it, especially if there's a possibility this path could change. So because this is such a dangerous method, what I suggest you use if you find yourself needing to remove files is the send to trash module, which is actually an outside module you need to download. So you need to pip install send to trash at your command line. So open up your command line and type pip install send to trash, and then you should be able to import it. So send to trash is safer because it will send things to the trash bin instead of a more permanent removal. Okay, so again, OS module, it can delete files, delete empty folders, or delete everything within a folder, including all the files in it, but it's pretty dangerous to work with because it's a permanent removal instead of moving things to the trash bin, which is why I recommend if you do find yourself doing this, check out send to trash first. So let's explore send to trash. I'm going to come back here, and what I want to do is, after you've done installing it, import send to trash. There we go. And let's check everything that's in my directory. And I currently don't have that practice file in my directory, so let's go ahead and get it back. What I'm going to do is say shell utilities, grab the practice.txt file, which is currently located under my username, and then I have to figure out where I want to move it to, and I will move it to my current working directory, which I can simply say os.get current working directory. So that says grab that practice.txt file and move it back here. So I run that, it reports back now its location, and if I try to list these directories again, I now see practice.txt file has been moved back to my current location. Let's go ahead and send this to the trash. It's actually quite easy to do. You simply say send to trash dot send to trash, and then you just provide the full file path or file of what you want to send to the trash. So I will send this practice.txt file to the trash, run that. It's now in my trash bin. It hasn't been completely removed. I could recover it if I really needed to. And say os.list directory, and now I no longer see that practice.txt file. And now the last thing I want to show you in this lecture, which is probably the most useful, at least in my opinion, functionality of the OS module, is os.walk. And if you type os.walk and do Shift-Tab here, it essentially takes in one parameter, top, and it says it's a directory tree generator, which essentially what that means is for each directory in the directory tree rooted at the top, it's going to yield a tuple. The directory path, the directory names, and then the file names. So the way I like to think about this is by creating a for loop. So we'll say for folder, comma, subfolders, comma, files. This is tuple unpacking in os.walk. And if you want, you can pass in your current working directory, but the reason I recommended you follow along in the same location we did is because I'm going to take a look at, if you go to Advanced Python Modules, up here I created an example top level folder. If you click on example top level folder, notice there's two folders within it, midexample1, midexample2, and there's an actual file within the middle, midexample.txt. If you then go to midexample1, notice there's two bottom level folders, some mid-level document in here, and then there's one text, etc. Bottom level 2, there's bottom text 2, come back up levels, go to mid-example 2, and this one is empty. So what I want to do is actually pass in the file path for this example top level, and this should give you a good idea as well as a simple comparison to be able to understand how os.walk is reporting back results. So I'm going to come back here, and I'm going to say the following. I'm going to say os.walk, and let's go ahead and actually grab the directory for this example top level file. And the way to do that is, let me insert a cell above this and quickly grab our current working directory. So I'm going to grab this guy here, paste it in, and in fact let's do this on 2 lines so it's a little easier to read. So we'll say file path is equal to, and then we have this kind of long file path here, users, etc. And I'm not just going to look at Advanced Python Modules, I'm going to say // example underscore top underscore level. Note my capitalization here. Okay, and let's actually put this in a separate cell. So there's my file path. I'm going to look directly at example top level. So we'll say for folder, subfolders, files in os.walk for this particular file path. If you want, if you're operating on a different computer and for instance you don't have access to our specific Advanced Python modules, you can replace this with os.get current working directory in order to explore what we're talking about here. But to get the same results I do, go ahead and check out this example top level folder. And then inside of this, we'll add in a couple print statements so we can clearly see what's going on. I'm going to print using, let's say, f-string literals here, currently looking at, and then I'm going to report back the folder I'm currently looking at. I'll print a new line with \n, and then I will print the subfolders, or really subdirectories, are, and now let's report back for every subfolder. We'll say for every subfold in subfolders, print, and what we're going to do here is again f-string literal, subfolder, and then what I'll do here is paste in that subfold. So it's going to report back the folder, and then I'm going to go through each subfolder or subdirectory within this, and then I'm going to print a new line. I'll do the same thing for the files. We'll say print the files are, and for F in files, I'll say print F string literal here, file. Let's type in that F there to print out the file name. And once this is done, I'll print out a new line. And just for more organization, what you could do if you want, you can add in tab spaces. So essentially \T is a tab. So we can do that within these. So it says currently looking at folder, it'll list the subfolders indented, and it'll list the files indented. Let's go ahead and run this, make sure we didn't commit any typos. Looks like I have one minor typo. I accidentally said subfolders instead of sub_folders. Let's fix that. And there we go. Okay, so what is this actually looking at? It reports back, I'm currently looking at this folder, example top level. Recall, that's what I have here, example top level. So we're going to kind of do this comparison. It reports back the subfolders, mid-example1, mid-example2. So if I take a look here, I see mid-example1, mid-example2. Note these are folder directories. It's not just a single file. It says the files underneath this are file mid-example.txt. Now what OS Walk is going to continue to do, it's then going to open each of these subfolders and report back, hey, now I'm looking at mid-example1. Here are the folders within mid-example1, and here's the file within that. Now I'm going to look at bottom level 1. So now it's looking at this subfolder. It says file 1 text is located in there. Now I'm going to look at the other one, bottom level 2, bottom text 2 is located there. Then we're going to go back up and now view mid-example 2. There were no subfolders there and there were no files there. So if you recall, mid-example 2 was just empty. So we can see here that OS Walk, what it's going to do is essentially make a tree, and it's going to look at every single thing inside of this file path location. It's going to look at the folder, it's going to look at the subdirectories or subfolders, and then it's going to look at the files. And hopefully what you can do then is add in logic. So maybe you're looking for every text file within a certain directory that starts with the year 2010 or 2020 or something like that. Well, you could use this and then have some sort of if statement to check the file names. And now you can very quickly and programmatically look within directories within directories. So OS Walk is extremely useful. It takes a little bit of time to get used to this sort of kind of tuple unpacking as well as the way the tree directory actually works. But hopefully this example kind of allows you to have a relationship between what is reported back versus what is actually there. So I would highly recommend you run this on the file we created, example top level, in order for you to make the direct comparison to understand how it's looking at files, subdirectories, and the actual raw files. Okay, if you have any questions, feel free to post to the Q&A forums. I'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to give you a brief tour of the datetime module, which essentially allows you to create objects that have information not just on the date or the time, but also things like time zone and operations between datetime objects, such as how many seconds have passed or how many days have passed. Let's check this all out in a Jupyter Notebook. All right, to begin using datetime, let's first explore the time factor. To do that, I'm going to first say import datetime, and then we're going to create a datetime object. So I will say my time is equal to datetime.time. And if you do shift tab here, you'll notice it takes a couple of arguments: an hour, a minute, a second, a microsecond, and then time zone information. If you do not provide certain information, it's just going to automatically fill it in. For example, let's only provide the hour and the minute. So let's go ahead and say it's 2 a.m. So notice it's going to work on a 24-hour clock. And then it's 20 minutes past 2 a.m. So now, if I take a look at this my time object, and I hit .tab after I've defined it, I can actually access things like the minute. So this is an attribute, and I can see the minute portion is 20 minutes. and I can check that the hour portion is 2 hours. Again, this is running on a 24-hour clock. So if I actually just print out my time, it's going to print out 2:20, and then it'll automatically fill in the seconds with 0. Let's imagine I only defined hour 2, and I rerun this. It'll automatically fill in minutes as zeros, hours 2, and when I print the time, it says it's just 2 o'clock. Everything's kind of filled in with zeros. Now, this can actually go up to microseconds. So you could, if you wanted to, give microsecond level information. So in this case, it'll automatically fill it in as 0. But if you did want that sort of information, you would just keep going through the levels. So hour, minute, second, microsecond, and even time zone information. So you can go all the way for something like, if you want to be very precise, you can do, let's go ahead and do something kind of in the PM. So 1300 hours, 20 minutes, 1 second, and then 20 microseconds. So if you run this, you can see we get all that information back, and you'll notice that it continues on with the microseconds. If you don't define microseconds, it won't bother to display them for you. And again, microseconds typically are using that in a more scientific setting. Okay, now we saw that this time instance, if we check out what type of object my time is, it's a datetime.time object. So it only holds values of time. It has no date associated with this. What we could do, though, is add in date information using a date object or a combined datetime object. So let's begin exploring date objects themselves. To do this, I'll say today is equal to, then we'll say datetime.date. And if I wanted to, here's where I could begin defining the year, month, and day. Or I could grab information on today by using the method call today. And now, after running that, I can print out today, and it'll say it's 2020, June 12th. So notice here, the format follows the European kind of standard, which is the year, the month, the date. And in general, most programming languages will follow this sample from kind of the largest timescale, years, to smaller and smaller, months, days, and so on. And just as you might have expected, all of these are attributes. So I can grab the year, the month, and the date as well, or the day. So 12, which means I can grab portions of this. And Python also allows you to return something called ctime formatting, which is just another way of formatting this along with some time information. So I can say, go ahead, grab today, call ctime on it, and it'll print it out in this format where it will give you the day in 3 letters, the month, the date itself. If you added time information, which we'll show you how to do in just a second, it'll be there, and then the year itself. So sometimes certain databases store time in this format, so it might be useful. So let's say now you don't just want date information, and you also don't want just time information. You actually want date time information, so information that combines both of these. You can say from datetime import, and this is where it looks a little weird. You actually import datetime from datetime because the object happens to be the same thing or called the same thing as the module because it combines both date information and time information. And if we take a look at datetime, notice now it takes in both year, month, and day, as well as everything from hour, minute, second, microsecond, and time zone information. So all of that now is available to you. So I could do something like, let's see, the year 2021, let's say October 3rd, and then I can continue on to the actual hour. I can say it's going to be 1400 hours, 20 minutes, and let's say 1 second. And now I can see I have this datetime object. So I can say my datetime is equal to this. And now I can call all that information, or I can just print it out. So we run this and we see the information printed out here. Again, going from the largest timescale, year, down to the smallest, month, day, hour, minute, second, and so on. Now, for some reason, you made a mistake or you need to do some sort of replacement. Like for instance, I accidentally said 2021 and I need this to all be in 2020. I can do that with the replace functionality. So I can take my datetime object, call replace on it, and then I simply say what the attribute I want to replace is, such as the year, and then specify that it should be another year, like 2020. We run that, and now it returns back the same information, but with whatever you want to replace, replaced. And what I could do is then update it. So this doesn't actually happen in place. I'd have to say my date time is now equal to this. And now when I print my date time, it's supposedly fixed if that's what I need it to fix. So you can use the replace parameter or method call in order to do that to your current dates. Now, something that's really common to perform with datetime objects or date objects is just simple arithmetic. For example, let's say someone logs in to your website on a certain day and then they log back out on another day or at a certain date time, and they leave at a certain date time. You probably want to figure out, well, how long did they spend on my website or how long did they spend logged in? And we can perform simple arithmetic to solve for these. And you can perform arithmetic either on a date object or a date time object. So we still need that date information there. Let me show you a couple of examples. Let's first do it with just pure date information. And date, recall if we come up here, is datetime.date. Alternatively, it's the same thing as saying something like from datetime import date. So it's up to you which one you want to use. Let's create two dates. Going to create date 1, and let's just say this is sometime in the future. Go ahead and say maybe 2021, and we'll make this November 3rd. And date 2 is going to be, let's say 2020, November 3rd. What I can do is actually perform direct arithmetic on this to figure out the difference between them. So I can say how much time is between date 1 and date 2 by taking this one in the future and subtracting this one. So I run this, and it returns back this time delta object. And as you might have guessed, if you take the difference between two date objects, it reports back the difference in number of days. And we could do something like result is equal to date 1 minus date 2. And if you check the type of this result, it's a special time delta object, which has its own properties and attributes, which you could find useful sometimes. So you can actually just call how many days have passed, run that, and it returns back 365 days, which makes sense because these are directly a full year apart. Something to keep in mind, though, is that if you're doing this for really long distances between years, that is to say, you may have issues with leap years. So it may not be exactly 365 days per year. Instead, you may encounter a leap year with an additional day. All right. So the other thing we can do is perform arithmetic on a date time object. And we can either call this with datetime.datetime, or as we saw here, say from datetime import datetime. Let's create two datetime objects. We'll say datetime1 is equal to datetime, and let's go ahead and use the same dates. And then what we're going to do is say 1 occurs at, let's just say 2200 hours. So that's datetime 1. Recall 22 here is hours, this is minutes. And then datetime 2 is equal to datetime. And let's do the same dates. They're 1 year apart, but we're also going to make them, let's say, 10 hours apart. So we run that, and now let's go ahead and check the difference between datetime 1 minus datetime 2. Run that, and now it returns back 2 points of information, total days, and you'll notice it returns back total seconds. So it's returning back 36,000 seconds. We know these are 10 hours apart, so I can check on this by saying 36,000 divided by, if we want to figure out maybe how many hours apart they are, I could say 36,000 divided by 60 to get minutes, divided by 60 to get hours. We run that, and we get back those 10 hours. If I save this as a result, let's copy this, say my difference is equal to datetime 1 minus datetime 2. You'll notice there's attributes here, and I can actually grab the total seconds, or seconds, between them, which is 36,000. If I say my diff, and the total seconds is then now inclusive of not just the seconds in between them, but also how many seconds are in 365 days. So this is just the seconds portion. This is everything reported as seconds. That's it for this brief lecture on datetime module. You'll often find yourself encountering this if you're ever dealing with a database. Thanks, and I'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to discuss two built-in modules. One is the math module. It's essentially just a module that holds a ton of useful math functions. We won't go through every single one, but we'll show you how to find them. And then there's the random module that contains a lot of mathematical random functions, as well as random functions for grabbing a random item from a Python list. We've actually already seen a little bit of random with random shuffle, but let's explore these in more detail. You can check out the links in the lecture notebook if you're looking for a link to the documentation online, or you can just Google search math Python module and your first link will be the official documentation. Let's head over to a Jupyter notebook. All right, here we are at the Jupyter notebook. Let's go ahead and start off with the math module. Going to import math. And if you want to figure out what's available to you in math, you can actually just call help math, and it'll describe that this module is always available and essentially has a bunch of mathematical functions available. It's everything from trigonometric functions like arc cosine or hyperbolic cosine or inverse hyperbolic cosine, all the way to simpler things like taking the floor of a number, essentially just taking the largest integer that is less than or equal to x, and so on. We're going to explore just a couple of these functions, and the rest I'll leave it up to you if you ever need them to just look it up in the documentation. But just always keep in mind that if there's a basic mathematical function that is common enough to be found in any mathematics textbook, it's probably available to you inside the math module. You just need to say from math import whatever function you're looking at, or just call math.function. So let's go ahead and check this out. So let's see how we can round numbers. If we have a value called 4.35, for instance, there's a couple different ways we can do this. Using the math module, I can say floor, which essentially is going to bring this down to the integer that is less than or equal to the value. So that should be 4. And then I can do ceiling. So if I said math.ceil for ceiling, it essentially works the other way, giving you the next integer up. So it essentially rounds up regardless if it's closer or not to that floor value. If you want essentially a true rounding, so you can call round. It's actually built into Python itself. It's not part of the math module because it's common enough to use. So if you just say round 4.3 or 4.35, since it's closer to 4, it will round it down. And if you do something like round 4.5, which is kind of right in the middle, it'll go to 4. But notice what happens if I say round 5.5, it goes to 6. So what's actually happening here? Why is one going down and one going up? It's because in general, you want to choose to always round to either all evens or all odds when you're starting to, for instance, create some sort of set of rules. And the reason for that is if you always chose to round down when it came to a 0.5 split, something right in the middle, then all your estimates over time would be lower than they should be. Or if you always chose to round up, then over time, all these rounding errors would be higher than they should be. If you choose a rule based off a number being even or odd, then you start to even itself out because you'll round down as many times, hopefully, as you round up. So that's why you'll see this round at 0.5 go towards the even numbers, like 4 and 6, when it comes to some split right down the middle. Okay, let's show you how you can grab mathematical constants. So you can call these right off of the math library, such as mathpy, and that gives you the mathematical constant pi, or if you want, you can say from math, import pi, and then just use something like pi in your code. There's also e, very common number, and there's representations of things like infinity or not a number. So math, infinity, or math, not a number. Something I also want to point out, if you find yourself that you're working with heavy enough mathematics that you're going to be using math.infinity or math.not a number, you may want to check out the NumPy library. That's NumPy. Check it out online. It's a library specifically designed for numerical processing, and it's highly efficient and goes much deeper than Python's built-in math module. But for our use cases in this course, the math module is more than enough. Finally, let's go ahead and see how we could do logarithmic values with the math function. So here we have math e, so we have 2.71, and if you take the log base e of math e, it should give you 1. So what does this actually mean? Essentially, it's just the base to the power of some n is equal to the variable you provide. So let me show you this by showing you how to create a custom log base. So I will call math.log you'll notice it provides an x, and it's up to you to provide a base. Return the logarithm of x to the given base. So if I say 100 is x, base 10, it returns back 2. So what is that actually solving for? It's solving for what number do I have to take 10 to the power of in order to get 100. So that means I'd have to do 10 to the power of 2 to get 100. So if you're not familiar with logarithmic, just mathematics in general, then you probably won't be using this in Python anyways. And finally, there's trigonometric functions, another really useful one. You can take math sine of some number, it returns it back. In radians, if you want to turn it into degrees, you simply say math.degrees. It can convert something from radians into degrees. For example, pi over 2 in degrees is 90 degrees. Or math radians, 180 degree in radians, whoops, make sure we spell that right, is going to be equal to pi. Again, that's just basic trigonometry, and that's all within the math module that's built into Python. Let's move on and discuss the random module. The random module allows us to create random numbers, and we can even set a seed to produce the same random set every time. Now, an explanation of how computers attempt to generate random numbers is really beyond the scope of this course because it actually involves some pretty high-level mathematics on how computers use what are known as pseudo-random number generators. Now, I've linked 2 Wikipedia articles in case you are interested in this in the lecture notebook. So if you check out the lecture notebook, let me bring it over real quick. When we discuss the random modules, there's 2 useful links here. One is discussing pseudo-random number generators. It's a really interesting field of mathematics, really interesting history on how you can actually get a computer to show something that looks random, as well as random seed, which is then how can you get the same batch of random numbers if you want to test the same code over and over again. So let's go ahead and start trying to understand a seed. Let me bring this back over here. To begin, I'm going to import random, and let's start by checking out the random.randint. So if we check out what this function does, it just returns a random integer in range a and b, and it includes both endpoints, which means if I type in right here 0 and 100 and run this, it's going to return back some random integer. If you ran this, it's more than likely than not that you got a different number than I did. It's basically a 1% chance that you got the same number I did. And every time you run this, you'll notice you start getting back a different random integer. It's possible that you get the same one in a row, but that's 1 over 100 times 1 over 100 chance. Okay, so we know we can produce random integers. However, what if I'm testing a code script and I want to make adjustments to this script of code, but I want to test it on random numbers, but the same batch of random numbers? This is where the seed comes into play. Setting a seed allows us to start from a seeded pseudo-random number generator, which means the same random numbers will show up in a series. Okay, when it comes to running this within Jupyter, in order to make sure this works, your seed should be in the same cell as whatever function you're using to generate random numbers. So we call random.seed, and then it's up to you to choose some seed value. Note, this value is completely arbitrary. It can be whatever you want. Often people do 101 just because it's easy to remember and it looks nice. Other times people, especially libraries, often use 42 because of Hitchhiker's Guide to the Galaxy. It's just a reference to that. But again, this value right here is completely up to you. It's totally arbitrary. So we choose that seed, and in the same cell, what I want you to do, if you're following along with me, is call randint, and then 0, 100. Go ahead and run this, and if you set this up, both for the seed, the same value I did, you should have gotten the same random integer if these were in the same cell. So notice here, we get back 74. And note what's going to happen. I'm going to run this again one more time. Again, I get 74. It doesn't matter how many times I run this cell, I always get back 74 because the seed's set. And the seed essentially starts the same series of random integers. So if I copy this and paste it in the next cell, if I run this, I will get 24. And if I run this one, I'll get 69. However, let's go ahead and reset our seed. Notice now all 3 cells keep repeating those same random numbers. But if I take one of these and I haven't set the seed or reset it again, and I keep calling this one, I'll get the same series of random integers. each time. So essentially what that means is if I were to print these out, let's go ahead and copy and paste this a couple times. Let's print this out 5 times, and we'll reset the seed within this cell. What I should expect is that this first one produces 74, and that this next one produces 24, since I can see right here that it goes 74, 24, and I believe the next one was 69, and so on. So when I run this, I get back those results, 74, 24, and 69. And that's because I set the seed right before calling that first random integer. So the thing I really want to clarify here is just because you set a seed doesn't mean that every time you call random integer, it'll always return 74. Instead, you should think of it as setting a seed for any sequence of basically infinite random numbers. Okay, so we already know that we can grab random integers using the randint function. There's a couple of other functions I want to show you with the random library. The first one I want to show you is taking just a random item from a list. So I can say my list is equal to list range 0 to 20. So now I have a list of a bunch of integers, 0 up to 19. And let's imagine I wanted to grab just a random item from this. I could say random.choice, my list, run this, and it chooses some random integer from this. In this case, it was 16 for me. Keep in mind, this does not permanently affect your list. 16 is still there within your list. Now, that's just for grabbing one item. Let's imagine you want to grab multiple items. Let's say I want 5 random numbers from this list. Well, there's 2 different ways of doing that. One is to allow yourself to pick the same number twice. So that's sampling with replacement. Or you sample without replacement. Means once you've picked out an item from this list, you can't pick it again. So let's show you first sample with replacement. So again, that's going to be allowing the same integer in this case to be chosen more than once. And the way that works is we call random.choices. And there's 2 main parameters here. It's the population, what you're actually picking from, which is my list, and then k, which is how many items you want from this. Let's make k equal to 10. So that means I'm going to randomly pick a number from this list. I'm going to do that 10 times, and it will return a list of those numbers. Since I'm sampling with replacement, I should be able to see some numbers duplicated. And with k equal to 10, it's highly likely that you picked the same number at least twice. So here we can see 4 was chosen twice, as well as 1. Actually, 4 was chosen 3 times. Okay, so that's sampling with replacement. Now let's imagine I want to sample without replacement. So what does that mean? It means that once I've chosen a number, I don't get to pick it again. And to do that, that's going to be random.sample. Same parameters. We provide a population, my list, and if I say k is equal to 10, we run this. Notice that none of these numbers are repeated, because once you picked it, you're not allowed to pick it again. Okay. Finally, we can show you how to shuffle a list. Keep in mind, this will permanently affect the list, so you don't need to actually assign the result to anything. So here's my list. If I wanted to shuffle it in place, I can say random.shuffle, my list. No, I do not do any sort of reassignment. It just does it in place. So the list is permanently affected. And in case you're interested in probability distributions, there are a few that are available to you in the random library. So there's a uniform distribution, in case you're familiar with it, which is essentially just going to randomly pick a value between A and B. So let's say A is equal to 0 and B is equal to 100. This is a continuous distribution, so that means floating point numbers are allowed. So it can pick any number between 0 and 100 up to a very large floating point precision. So it's not just integers. So you run this, and in this case, I chose 0.65. And the reason that it's called uniform is because every number between 0 and 100 has the same likelihood of being chosen. Now there's also a normal or Gaussian distribution that you can choose. So that's callable by random.gauss. And this takes in a mean and a standard deviation. If you're not familiar with that, then don't worry about it. You probably wouldn't be using this if you don't know what a normal distribution is. But in case you do know, you should be aware that it is available to you within Python's built-in random module. This is a Gaussian or normal distribution centered at 0 with a standard deviation of 1. We run that and it picks just some random value from that. So something I want to note is if you're using Python to the point where you find yourself calling uniform random distributions or random normal distributions, you should really look into the NumPy library. We teach it in some of my data science and machine learning courses. You can check it out there, or you can just check out the free online documentation. It's a really powerful library, and I would highly recommend that if you're calling random.uniform or random.gauss, you just start switching over to NumPy at that point. Okay, thanks, and I'll see you at the next lecture. Welcome everyone to this lecture on the Python debugger. When trying to figure out what errors there are in your code, you've probably used the print function to try to track down the error by printing out variables within your Python script. Fortunately, Python comes with a built-in debugger tool that allows you to interactively explore variables within mid-operation of your Python code. Let's check it out by hopping over to a Jupyter Notebook. Okay, here we are in the Jupyter Notebook. First, what I want to do is to show you an example of an error and then how you would try debugging it with just using print statements versus how the Python debugger can be kind of a more powerful interactive tool for you. Let's begin by having, let's say, a list. So we'll say X is a list, 1, 2, 3. Y will have that just be 2, and then Z, let's have that equal to 3. And in the same cell, I'm going to say result is equal to Y plus Z. And let's go ahead and say result 2 is equal to X plus Y. Whoops, that should be X. There we go. All right, so notice here, this should induce an error because while I can add two integers together, it doesn't make sense for me to try to add a list with an integer. It doesn't make sense to say 1, 2, 3 as a list plus 2. So that's not allowed. And if I run this, it reports back the type of error that's happening here. It says, can only concatenate list, not integer to list. So I can add a list to a list through concatenation or a number to a number. But let's imagine your error is a little more complicated than this. You get some sort of error report, but you're still not sure what exactly is going on. Well, you could try to begin putting in print statements or print function calls. Maybe try printing out the results on both to see if that helps. Maybe try printing out what Y is, and you keep running this, but you'll notice that eventually the type error may show up. It shows the same type error information. Let's imagine that you still don't understand what that error is, and at a certain point, you're just adding too many print functions to really try to hone in on what the error is. This is useful, however, because we did get to see at least that the first result printed, so we know the error sometime after this. But what we're going to do here is show you how you could use the Python debugger to set a trace. So I'm going to remove, for now, these print statements. Let's go ahead and just have these three variables. And what I'll do in a new cell is import pdb, the Python debugger. And then what I'm going to do is, let's copy again these three variables, and then I'll say result 1 is equal to Y plus Z, which does work. And essentially the same code we had last time. Result 2 is equal to Y plus X, which we know won't work. So you run this and you get your error. Now what you could do is use print functions as we did before, or you could set a trace using Python debugger. And the trace is essentially going to pause operations mid-script and then allow you to play with variables to understand what's going on. That way you don't have to keep adding in print functions to try to figure out what result 1 is, what Y is, what Z is. Because you can imagine that these variable definitions could be way further up along in your code and not easily readable like we have here in such a short script. So what I'm going to do is I'm going to set a Python debugger before my error. So note that the type errors will report what line the error occurs on. So this is occurring on line 7. And what we're going to do here is right before this result 2 is equal to Y plus X, I'll set my trace. So you should be setting your trace before the error line. So let's go ahead and set our trace by saying pdb.set_trace, open close parentheses. And let's see what this actually does. Okay, so you just ran that, And now it says Python debugger set trace, and you'll notice it says XYZ, result 1, and so far we haven't actually printed anything out, but we do know that result 2 is going to give us an error. So what does the Python debugger allow us to do through this little interactive environment? Well, it allows you to actually explore and call variables at this point in time. So I know that I'm currently at this line right before result 2 because I set the trace there. And then I can call variables like x, and it'll report back what they are. So basically, I've paused this operation mid-script, and then I can begin exploring what things are. So I can then ask, well, what's result 1 right now? Mid-script, it says it's 5. And then what is y, 2? So here, I could then explore, well, at this point in time, what is y? I see that it's 2. And at this point in time, what is x? I see it's a list. And hopefully, this can then help you figure out what variables are interacting with each other. And often, sometimes a variable is none, and you try to interact with it, and it's not able to perform operations because it doesn't have an actual value associated with it. And hopefully, this would then help you figure out, oh, I can see here, I'm trying to add an integer to a list, and that's the source of my error. Keep in mind that Python debugger will still call on you, the user, to try to look up the error code, understand what's going on. Its main tool is for you to figure out in a very large Python script what variables are assigned to what in order to help you debug, especially in mid-operation, where at a certain point you've been reassigning a variable to certain operations or to certain outputs of functions, and you may not know clearly what it is at a certain point in time in your script. Python debugger essentially allows you to put a pause right in the middle of your script in order to explore variables, which is very useful instead of having to flood your script with print function statements in order to figure out what variables actually are. Okay, and then once you're ready to quit the debugger, you can just type in Q here, hit enter, and it will report back that you quit the debugger. So there you go. Now you can definitely check out the official documentation for the debugger. It comes with a lot more tools, but definitely this one of setting the trace is its main functionality. So if you check out the lecture notebook, we have a link here to the Python debugger documentation. You can see here how they're setting traces and calling modules, etc. So again, set trace is what you're mainly going to be using this for, but there's other options here you can check out in case you're interested in, and there's other debugger commands as well. Okay, thanks, and I'll see you at the next lecture. Welcome back to this series of lectures on regular expressions, and this is part 1. We already know that we can actually search for substrings within a larger string with the in operator. Here's a very simple example. I could check if dog is within a larger string of text by saying the string dog in my dog is great. And in this case, it would return back true. Now we can already see this has severe limitations. We need to know the exact string we're looking for, and we need to perform additional operations to account for things like capitalization and punctuation. So what if we only want to search for a pattern structure of a string we're looking for? That is to say, what if we know that we're looking for an email, but we don't know the exact email we're looking for? We're just looking for all the emails within a document. Or we're looking for something like a phone number, where we know the general structure of the way a phone number is presented, but we don't actually know the exact phone number we're looking for. This is where regular expressions, or regex for short, allow us to search for general patterns in text data. For example, let's go back to that email. We know that a very simple email format could be something like user@email.com. And we know in this case, for this very particular domain, if I wanted to find all the emails within a very large document of text, I know I'm looking for some pattern of text@text.com. So essentially what we're looking for is what we don't actually know exactly or precisely. That is, I know there's going to be some text for the username, and I know there's some sort of domain name, and then I have the things that I'll assume I do know. In this case, I will assume that there's an @ in between the user and the domain, and in this case, I assume the domain name ends in .com. I know there's other domain names, .io, .xyz, etc. But for this particular pattern, let's say I'm only looking for emails that end in .com. So what I can use regular expressions for is to construct a generalized pattern to search for something like this. So Python comes with this built-in regular expressions library, or RE for short, and you import it as RE. And the RE library allows us to create specialized pattern strings and then search for matches within text. And the main point I want to get across right now is the primary skill set for understanding regular expressions is really understanding the special syntax for these pattern strings. And I don't want you to feel like you need to memorize all these patterns. Regular expressions are notoriously difficult to memorize and understand. What you should really focus on is understanding how to look up the necessary information so you can quickly find the appropriate or correct patterns. Especially if you don't use regular expressions that often, you won't find yourself memorizing these specialized syntax codes. Instead, understand how to convert what you're looking for into a specialized pattern syntax, and then you can look up the necessary patterns, quantifiers, or identifiers that you need. So here's a simple example of what a generalized regular expression could look like. Let's imagine I'm looking for a phone number, and I know that it's in this format somewhere within a very large document. I know it's going to have 3 numbers in parentheses, a dash, another set of 3 numbers, a dash, and then a set of 4 numbers. An example regular expression pattern could look like this. So let's focus on what's happening here. Notice that outside of the string, there's an R, and that basically informs Python, especially when you're using the regular expression library, that don't treat this as just a normal string. There's actually identifiers within this string. And you'll notice that there's a bunch of backslashes, which corresponds to the individual identifiers. So these identifiers are essentially just placeholders, almost like wildcards, waiting for a match based off a particular data type. And in this particular case, \d stands for digit. So this is essentially saying I'm looking for 3 digits in a row. It doesn't actually care what the digits are because we don't know what the digits are yet. We just know that they're going to be in this format. And then you'll notice the other strings that are present are the format strings themselves. I know there's going to be parentheses, I know there's going to be a dash, I know there's going to be another dash there. And those, you'll note, don't have a backslash associated with them because they're not an actual identifier for a regular expression. We're actually looking for that exact string. So again, we have these general identifiers and then the exact strings we're looking for. And this in turn constructs a general regular expression pattern. Now this is kind of the most simplified version of one. They can begin getting more complicated. You'll see here, this is a regular expression pattern that actually solves the exact same problem as the one before, but now it's using things like quantifiers in order to reduce the amount of text you actually have to write. So this is essentially saying find 3 digits in a row, and then another 3 digits, and then another 4 digits. And we're going to learn how to do this throughout this series of lectures. Okay, so we're going to start off first in this particular lecture is focusing on how to use the regular expression library to search for patterns within text. And then afterwards, we'll focus on understanding the actual regular expression syntax codes, those patterns that we just saw earlier, like \d, identifiers, qualifiers, groupings, and so on. Okay, let's get started. I'll open up a Jupyter Notebook. Let's begin by understanding how to search for basic patterns. We'll create some example text saying something like, the agent's phone number is 408-555-1234. Call soon. As we just discussed, you could search for simple strings in the text, such as phone, in, text, and you would get back a Boolean indicating true or false is that actual string in the text. But now let's show the format for regular expressions. To do this, we will import the regular expressions module, RE, and then we'll assign the pattern phone to a variable called pattern. So we'll say that the string phone is equal to pattern. Then we can say RE, call the search function off of the regular expressions module, and then you pass in the pattern, and then you pass in the text, and you get back this match object. And so notice how much more information is here. This match object will report back not just whether there was a match to the phone, but also where the actual index location spanned to. So it starts at index 12 and then ends at index 17. So now let's search for a pattern that we know is not in the text. So we'll create another pattern variable or really overwrite it. And then something like not in text, which we know isn't there. And if we search for the new pattern in our text, we get back none, which means we don't really get back anything because there is no match. So now that we've seen that this re.search function will take the pattern, scan the text, and return a match object, And if no pattern is found, none is returned, which in the notebook setting just means that nothing is output to the cell. Let's take a closer look at this match object from before. We're going to reset pattern as phone, and we're going to run this search again. We'll say re.search pattern in the text, and we'll actually save this to the variable match so we can explore this match object. So this is a regular expression match object, and it has a lot of information that we can grab from it. We can call the span method in order to get the actual index location of the span. And then you could also ask for the start or the end index by themselves. And keep in mind, if we had multiple matches inside the string, we would unfortunately only get back the first match. So if I had a string that said my phone once, my phone twice, and then I tried running the same command as before, saying match re search for phone inside of this new text, and then I check the match itself, it only turns back one span, 3, 8, because that's the first match right here. If I want to find multiple matches or all the matches, I can use the find all function instead. So I can say matches is equal to re find all, and I will search for, again, phone in that text. And then if I check my matches, I get back this list of how many matches I had. So if we wanted to check how many matches there were, I could get the length of this list. And if I want to get back actual match objects, then I use the iterator. So to show you what I mean by that, I can say for match in re find, and instead of find all, I can say find iter, and then pass in whatever pattern I'm looking for. So I could be looking for phone again, and then pass in the text I want to search. And what this does is it iterates through this text and then returns each match object that's found. So just like before when we were using search, we returned back the first match object, essentially indicating where we first matched up. If we use find all, it just returns back a list of the strings themselves. If I want to kind of combine these two by iterating through the text object and then finding every single match object, I use find iter. So you're going to need to essentially use a for loop with this to iterate. So we're saying for match in re.findIter, you pass in the pattern and the text you want to search for, and then you can print out the actual match object, and then we get back the match objects. And you can do whatever you want with these match objects. For instance, if you were just interested in the spans, you could call the span method off of it, run that, and it will return back the spans. Now, if you wanted the actual text that matched, all you need to do is use the group method. So you could say here, group, and that returns back the actual text that matched up that you were searching for, essentially what you get back when you use find all. So far, we've been able to realize the critical functions of the regular expressions module, and that is the search function, where again you just pass in a pattern and the text, and it returns back the first match object. The find all function, which again, pattern text, and it returns back just the list of matches indicating the strings that matched. And then the find iter, which is essentially a combination of these two, where you go through the entire string and you return back match objects for the actual pattern you're searching for in the text. Then you can call any methods you want off of that match object. What we haven't discussed yet is the actual special regular expression syntax for general patterns. Right now, we've only been searching for basic strings. Up next, we're going to discuss how to build these special identifying regular expression pattern codes. I'll see you at the next lecture. Welcome back. Now that we've learned how to actually do a pattern search using the regular expression library, it's time to continue our understanding with being able to build out these actual patterns with identifier syntax. So we'll look at a table and see how we can convert the items in that table to actual patterns. Let me head over to the Jupyter Notebook. We just discussed how to use regular strings for pattern searching when using regular expressions library. Now let's move on to the key part of regular expressions, which is the special pattern codes you can use to build out your own pattern sequences. We'll start off by discussing character identifiers, and here we have a table that tries to explain what each character identifier is. Basically, you'll have special character identifiers that start off with the backslash code and then a letter indicating what character you're referencing. So to start off, we can look at this example, backslash D, and this description is a digit. Essentially, you would have this as a placeholder for any digit. So in your example pattern code, you could have a string file underscore backslash D, and it would look for anything that holds that pattern, file underscore, and then 2 digits following it. For example, file underscore 25 would match this pattern code. Here we can also see there's alphanumeric, basically indicating letters or numbers, so alphabet or numerical, and that's backslash W, and this is what an example pattern code could look like, backslash W dash and then 3 backslash W's. And that basically says any letter or number followed by a dash and then followed by 3 letters or numbers. And alphanumerics also include things like underscores, so keep that in mind. Then there's white space. So if you're particularly looking for white space in the pattern, you can say backslash S, and that indicates a placeholder for white space. So an example pattern code for that would be the letter A backslash S, the letter B backslash S, letter C. And what this does is it indicates that you're looking for A, white space, B, white space, C. So here we have an example match. There's also a non-digit character placeholder, which is backslash capital D. And you can think of the pattern here as lowercase is a digit of lowercase d, and then uppercase D is a non-digit. So you can see how these are related to each other. And backslash D, backslash D, backslash D, where they're all uppercase, is going to match up with, for instance, this pattern, ABC, because none of these are digits, and they're all in a row with each other. You also have non-alphanumeric and non-white space, again, the capitalized version of their counterparts. So here you can see some various example matches. Let's begin by checking out that example with the telephone number. We will say our text variable is my phone number is 408-555-1234. And then we will say phone is equal to RE search. And if we actually search the phone number itself, 408-555-1234, in our text, we'll see that phone is that match object saying where it found it span. However, we may not always know the actual number. We just know the pattern, where it's 3 digits, a dash, 3 digits, and then a dash, and then 4 digits. So what we can do is replace this using the pattern character identifiers we just learned about. In this case, we're looking for a digit, so we will use backslash D. So we'll say backslash D, backslash D, backslash D. Then we expect a dash, 3 more numbers, another dash, and then finally 4 numbers. However, recall that when working with strings, these backslashes indicated special escape characters, such as backslash n for a new line or backslash t for a tab. To tell Python that we're using these as a pattern for a regular expression, what we do is we add an R right in front of the string. So that basically tells Python that these aren't really escape slashes such as new line or indicate tab. Instead, we're using them as a pattern for our regular expressions. So that's why you see this R in front of the strings when working with patterns for regular expressions. So let's rerun this cell and now see what our phone object is. And you'll notice the phone object is, again, the exact same thing. It's a match. But if I were to change these numbers around, so I said 7777 for the text and rerun these cells, it would still get the match. Before, it would not get the match because it's looking for the exact numbers. Here instead, we're doing a smarter approach where we're actually searching for the pattern itself. And if you ever wanted the actual number, you could say the phone object here, you see the span, and if you call the group method we discussed earlier on it, it returns the actual piece of string that matched. So this is how you could actually grab that phone number itself. Now notice what we did here. For every single digit in this phone number, we wrote a backslash D. But what if we were looking for a pattern that included 20 digits or 100 digits? We wouldn't want to have to write backslash D 20, 50, or 100 times. For this reason, we can use quantifiers to indicate repetition of the same character. So we already know our character identifiers. Now let's learn about the quantifiers, allowing us to not have to write these multiple times. So here we have the quantifiers table, and basically the way the syntax works is you stick your character identifier, and then immediately after it you stick this quantifier if you want to indicate a certain quantity. So you have various quantities you can choose from. there's the plus symbol indicating that the character identifier occurs one or more times. So an example of this pattern code could be version \w, so that's alphanumeric, dash \w alphanumeric plus. So what this plus indicates is that you're looking for \w one or more times. So an example match could be A-B1_1. So all of these are alphanumerics that occurred one or more times. Recall that underscore counts as an alphanumeric. Now let's imagine you wanted something to occur exactly n amount of times. So exactly 3 times, 4 times, you get the idea. You can use curly braces in that sense. So you would stick on your character identifier. In this case, we're looking for \D, indicating a non-digit, and we want this to occur exactly 3 times. So an example match would be ABC, 3 non-digits. If you want a range you're looking for example, occurs 2 to 4 times, it's the same curly braces, except now you indicate the lower limit, comma, the upper limit. So \d, curly braces, 2, 4. An example match could be 1, 2, 3. Another example match could be 1, 2, or 1, 2, 3, 4, because we're looking for a range here. Alternatively, if you're looking for 3 or more, or some n number or more, so you don't want to set an upper limit, you can just say curly braces, your lower limit, comma, and leave the upper limit blank. So \w along with curly braces 3, comma, no upper limit. Basically that just says 3 or more alphanumerics, go ahead and match them. So you can see any characters here, that string will match because it's 3 or more alphanumerics. And now you can see how regular expression code can get a little complicated quite quickly because you're adding character identifiers and quantifiers. But if you break it down, you'll be able to see what the actual pattern code is asking for. The next quantifier we can look at is an asterisk here, and that basically indicates if it occurs 0 or more times. So here we have an example pattern code, A, then asterisk, B asterisk, and then C asterisk. And what that is asking for, does A occur 0 or more times, followed by B occurring 0 or more times, followed by C occurring 0 or more times. So there are a ton of actual patterns this could match up to. For example, AAA, then 2 Cs. That indicates that A did occur 3 times, B occurred 0 or more times, and then you have C occurring 2 times. So very powerful here, and it's going to match a lot, so keep that in mind. And then you have a question mark here indicating once or none. So here we can see plurals, question mark, indicating does S occur once or none. And so an example match could be plural or it could be plurals. So either occurs once or no times. All right. Let's see how we could transform our original search for a telephone number using quantifiers. We'll place our example phone, but now we know the actual amounts we want, so we're going to replace this with our character identifier and then saying I want exactly 3 numbers, then a dash, then another 3 numbers, and then we want 4 numbers. And this is now a regular expression pattern code for a phone number with dashes. So we can run this and see that if we check our phone, we get back the same match here because we're asking for 3 digits in a row, followed by a dash, followed by 3 digits in a row, followed by a dash, followed by 4 digits in a row. Now let's imagine that we wanted to do 2 tasks. One was to find phone numbers, but then also to be quickly able to extract their area code. That is the first 3 digits of the phone number, these first 3 digits right here. What we can do is we can use groups for any general tasks that involves grouping together regular expressions, and that allows us to later break them down. So to do that, we need to learn about the compile function. So we will say phone underscore pattern is equal to re compile. And what compile does is it compiles together different regular expression pattern codes. For example, the first pattern code we see here, that's just a single pattern code. But what we could do is think about it as 3 pattern codes connected by this dash. So that's exactly what we're going to do here. We will say R, and then our quotes, and in parentheses, we're going to group together 3 pattern codes. So the parentheses indicate that it's a group of a pattern. So the first one that's going to go into first parentheses is this one right here, \D curly braces 3. So there's our first group, and then dash, and we're going to do our second group, which is actually the same thing. And then the third group is going to be with the 4 here. So what this does is it takes multiple pattern codes, and each pattern code is separated with parentheses as a group, and then it compiles them into a single expression. So what this is going to do is it's going to compile these into this expression that we see right here. But what's nice about using the compile is that it still understands that these were 3 separate groupings. So you could call the groupings individually. So we've created a phone pattern using the compile function. So if I say results is equal to re search, and I search for the phone pattern in my text, and then I say results, and I group them together, I see here 408, 555, 7777. Now what I can do is say results group and call them by the group position. And the groups were denoted by these parentheses. So if I want the first group, I can say group 1. And notice here in a little bit of a differentiation from normal Python code, we don't start indexing at 0, we're starting at 1. So group ordering starts at 1. So if I grab those results and I group, and I just say group 1, it only returns back the first group here. So if I wanted group 2, essentially that second set of digits, I could say group 2, and it would return back 555. And if I wanted the third group, I would say group 3, and it would return back 7777. And if I ask for a group that is outside of this, such as group 4, it's going to say, sorry, there was no such group. Because here we only had 3 sets of parentheses. First group, second group, and third group. What's nice about this approach in regards to our first approach is that now we can easily extract parts of that information while at the same time looking for a complete match. So if you just call group with no number, it groups together all the patterns you had in your compile function, and it returns back the whole match. So if you wanted to find phone numbers, you could just use this approach and then group them together. And if you wanted to find phone numbers and their area codes, you could use group with nothing and then say group 1, and that returns the area code. So that's why the compile function along with the group method is so powerful. That's it so far for quantifiers as well as the compile and group function. Up next, all we have left to talk about is some additional regular expression syntax, such as wildcard characters and then or pipe operators and stuff with like starts with or ends with. Let's quickly review what we covered here. Basically, we discovered that if we don't want to repeat character identifiers often, what we can do is use quantifiers. And we have various quantifiers indicated by a special character. Then there's a description here, and we can essentially tack them on. We also learned that if we want to grab subsections or subgroups of our entire pattern, we can use the compile function to create the actual pattern instead of just passing in the pattern as a whole string, separating each group with parentheses. And then we can say group together off of the search results in order to grab everything together. But if we only want to grab subgroups, we can say group and then that group position, where group positions start at 1. All right. We'll see you at the next overview where we're going to talk about some additional regular expression syntax. Welcome back to part 3 of the regular expressions lecture series. In part 3, we're going to continue learning about some syntax for regular expressions. Let's head over to the Jupyter Notebook. To finish off our discussion on regular expression syntax, we're going to discuss just a few more useful methods you may find yourself using out in the field. First off, let's discuss the OR operator. Sometimes you're going to want to search for multiple terms. You can use the OR operator to do this. For example, if we say re.search, and then the pattern we want to search for is a string, for instance, just the string cat, and we say search the actual string, the cat is here. If we run this, we get a match for cat. But if it says the dog is here, as you expect, we don't get a match. What if we wanted to search for cat or dog? In that case, we can use the pipe operator. So the pipe operator looks like that, and that stands for OR, meaning you can search for cat or dog, and then we'll get a match if there's a dog there or if there's a cat there. So that's the OR operator. There's also a wildcard operator, and the wildcard acts as a placement that will match any character placed there. So we'll use find all to show you an example of the wildcard operator. First, I'm just going to search for the string at or at, and I'll search for it in the string. The cat in the hat sat there. So notice I have 3 matches of at: cat, hat, and sat. But what if I actually wanted to grab the actual letter in front of at? In that case, I can provide a period, and that stands for a wildcard, meaning anything here, any wildcard there, attached to at. And then when I run this, I get back cat, hat, and sat. So again, the period can act as a wildcard for you. So notice how we're really only matching the first 3 letters, but if we had something longer, for instance, such as splat, so the cat in the hat will say went splat, what I could do is add more wildcards. So now I have, let's say, up to 3 wildcards here. So the cat in the hat went splat, so S-P-L-A-T. But keep in mind, these wildcard characters are also going to grab other letters and other spaces. So if I were to run this, I get back E space cat, E space hat, and then the full splat. And the reason I'm grabbing E space is because the wildcard characters are counting the stuff that comes before this first letter. So it's also counting this space and this E, as well as this space and this E for the cat and the hat. So keep that in mind as you use wildcard characters, the period. If you want more control, you'll want to use the character identifiers we discussed earlier. Again, period, essentially just a wildcard. All right, let's finally discuss starts with and ends with. So we can use this caret symbol. We'll show you in just a second. We'll say re find all. And if I want to find everything that starts with a number, what I can do is indicate this caret symbol or 2 power symbol. That's just shift number 6, and then type in what I'm looking for. So what this indicates is that the string I'm searching through starts with a number. So we'll say 1 is a number, and this returns a match for 1 because the entire text itself starts with the actual digit. Keep in mind, this is only for the entire text, not for a number randomly inside of this. So if I say the 2 is a number, I'm not going to get any matches here because it's only searching if the entire text itself starts with a number. So if I say 2 is a number, then I find my match for 2. Similarly, I can say ends with, and the way you do that is instead of a caret symbol, you just, at the end of this pattern, put a $sign, and that says ends with. So if I say 2 is a number, I don't get a match. But if I say the number is 2, then I do get a match. So again, $sign for ends with, and then this caret or power 2 sign for starts with. And then there's also ways you can use exclusion. So to exclude characters, we use this symbol, but we use it in conjunction with a set of brackets. So let's make a couple more cells here so we don't get confused by the earlier syntax. I'm going to create a phrase called there are 3 numbers, 34, just another number, inside 5, this sentence. Okay, so here I have a phrase, and it seems like there's just random numbers placed inside this sentence. What I want to do is find or get back everything that isn't a number in this sentence. So I want to exclude digits or exclude numbers. The format for that is the following. You'll say your pattern is equal to, and use inside of square brackets, just like you would for kind of a Python list, say whatever you want to exclude. So in this case, I want to exclude digits. So look at the syntax here. I have square braces or square brackets, this symbol, and then backslash lowercase d. So that just says exclude any digits. So anything that matches with this character identifier. And then if I say find all, pattern, and I put phrase here, I'm going to get back a list of every single character that was not a number. So I see there are, and then there's no number there, numbers inside this sentence. And what we can do is, if we actually want to get the words back together, I can add a plus sign to the end of this. Because remember, a plus sign, if we look back at our quantifiers, it just says occurs one or more times. So this is a nice way of regular expression to quickly remove things. So let's run these lines again. And now I can see there are, and it excluded essentially these groups of numbers. There are numbers inside this sentence. All right, so why would you use this exclusion syntax? This is a really common way to get rid of punctuation from a sentence. So we will say test underscore phrase is equal to, this is a string, exclamation point, but it has punctuation, period. How can we remove it? Question mark. Well, what we can do is the following. We'll say re find all, and inside of this, we're going to say square brackets, this symbol, and now I can add things I want to exclude. So I'm going to just put them in the same order. So I can say I want to exclude an exclamation point, I want to exclude a period, and I want to exclude a question mark, and then I can add a plus sign. So I just want to exclude those wherever they occur, and then we'll say test phrase, and now I get back the list. This is a string. Notice how it's essentially being split on any punctuation, but it has punctuation. How can we remove it? So there's no longer any punctuation there. And something else we can do is add a space here so that it will end up removing the spaces. And then I get back a list of all the words. Meaning, if I say this is clean, then now clean is all these words, and I can then join them. So I will say dot join clean, and I will join them all with a space itself. And then I get back, this is a string, but it has punctuation. How can we remove it? So these are some more complex tasks you can use with regular expressions. And obviously you can see here how this quickly can get very hard to read. So always break down regular expression pattern codes in order to try to help yourself understand what's actually happening. We're going to show you two more useful things you can use for regular expressions. And one of them is actually these brackets or braces here, these square brackets. And that actually is basically just for grouping things together. In the context of this caret symbol, essentially says group these things for exclusion, but you can also use them grouping for inclusion. So let's show a couple examples of that. We're going to create some text that says only find the hyphen dash words in this sentence, but you do not know how long dash ish they are. Okay, so we have this text, and basically the main point of this text is that I have hyphen dash words, and then later on I also have hyphen dash words. But note here how I don't know how many letters are before and how many letters are after this dash. So my main task is, given this piece of text, go ahead and find words that have a hyphen or a dash in the middle of them. So how would I do that? Well, the general pattern idea would be a group of alphanumeric words or characters, dash, and then some other group of alphanumeric characters. So the way we do that is by filling out the following pattern. The pattern is going to be braces, and then inside these braces I will say \w, and then I'll add a plus sign there. And what this indicates is just a group of \w. So remember, back from our character identifiers, lowercase w is just an alphanumeric. So it's basically looking for a group of alphanumerics. And remember, with the plus, we're essentially saying occurs one or more times. So we can check for this pattern. We'll say re.findAll, and then we'll pass in the pattern, pass in the text, and it finds back any groups of alphanumerics. Now, if I want to find the hyphenated words, I'll say a group of alphanumerics that occurs one or more times, dash, and then another group of alphanumerics that occurs one or more times, and then I can get back the actual hyphenated words. Now, if we were to remove these actual braces so that it looks like this, you would get back the same results. However, some programmers, because this looks hard to read, they like to separate groups using this brace notation. And the brace notation also allows you to kind of combine things together. So maybe you're looking for a word and then some digits for some reason. You can use those braces to do this sort of grouping syntax. So just keep that in mind. If out in the field, you see sometimes people using braces like this. Often you'll see braces used in these sort of exclusion statements, but they can also be used for inclusion. And then you can also use parentheses for multiple options. So if we have multiple options for matching, you can use parentheses to list out these options. So I'm going to copy and paste some code here very quickly, just from the notebook that goes along with this video. And we say text is equal to hello, would you like some catfish? Text 2 says hello, would you like to take a cat nap? And then text 3 says hello, have you seen this caterpillar? So notice how all of these start with cat, and then it says fish, nap, pillar. So if you wanted to kind of find the different options, what you could do is say search cat, and then you can use parentheses to kind of group together multiple options. So we'll say fish, nap, and then you could say claw. So let's see how this works. We'll say text. So when I run that, it finds catfish. So that was the first instance of that. And then if I say text 2, it says catnap. And if I say text 3, it doesn't find anything because I didn't say basically pillar. So I'm going to copy this and put that in there, pillar. And now if I check text 3, it finds the match. So all this is doing is allowing you to basically combine that OR statement we saw earlier with other pieces of text and provide multiple options. That's the basics of regular expressions, and you can check out the documentation page on regular expressions in the Python official documentation. It's linked to you at the bottom of the notebook for more information on regular expressions. Again, it can definitely very quickly get into some very complex looking syntax that is difficult to read, but always remember just the basics, where the main idea is you have some sort of character identifier and then attached to it some sort of quantifier if necessary. Welcome back, everyone, to this lecture on timing your code. As you learn more Python, you're inevitably going to discover multiple solutions for a single task, and you're probably going to find yourself trying to figure out what was the most efficient approach. So if you have maybe 3 solutions to the exact same problem, you want to choose the fastest and most efficient one. And an easy way to do this is to time your code's performance. In this lecture, we'll focus on 3 ways of doing this. One is to just simply track the time elapsed before and after calling your function. You'll notice, however, this has its limitations if your function is very fast for a small problem. Second way is to use the timeit module, and this is the most official way of doing this, and timeit module is actually built into Python. And then the third way is a special timeit magic function. However, this magic command only works for Jupyter notebooks, so if you're running this on something like PyCharm, you'll just have to use the timeit module or simply track the time elapsed. Let's explore all 3 of these methods in a Jupyter notebook. All right, here I am at my Jupyter notebook. In order to test timing code, we actually need to write some code. So what I'm going to do is I'm going to write 2 functions that essentially return the same thing. If you give them a number, such as 10, or let's actually make it smaller, like 3, what they're going to produce is a list of the string versions of those numbers, all the way, basically the integers, up to 3. So it'll produce something like this, or 0, 1, 2, if we decide to use range. Okay, so let me go ahead and start by putting a function. We'll call this one, let's say function 1. So function 1 takes in some number n, which is the top number, and it's going to return, and we'll do this through list comprehension. So we'll say for num in range up to n, go ahead and convert that to a string. So if we test out function 1, we pass in 10 there. It's going to go starting at 0, go all the way up to 9. Notice now these are strings. So it's just grabbing the number in range and then converting it to a string, returns it all as a list through a list comprehension. Now there's many ways of actually solving this problem. In an alternative way, we'll call it func2, or function 2, is to use the mapping function. So we'll say return list map, and we'll map the string function to range n. And if I call func2 and say 10, then we get back the exact same result. So what this is doing is you get the same values from range n, and then you convert them all to a string by mapping the string function to each number that results in range, and you convert that whole thing into a list by calling list on it. So you'll notice func1 and func2 are essentially two separate solutions to the exact same problem. It'll return back the same result. Now we want to know which one's more efficient. Well, one way of doing this is to time your code simply by marking a start time and then calculating the difference. And you can do this by importing the time library, and that is built into Python, nothing to install there. And essentially we're going to have three steps, which is grab the current time before we run the code, then we will run the code, and then grab current time after running code. And then just take the difference to get the elapsed time. So let's start with grabbing the current time. This is actually quite easy with the time library. You simply say something like start time is equal to time.time. This just grabs from your operating system what time it is. Then we run the code. So let's say result is equal to, we'll call function 1, and let's give it a larger n. So we'll give it an n of 1 million. So it's essentially going to pass in 1 million here, and you'll get a list that's 1 million string digits long. Then we calculate an end time. So that will be time.time after running the code. And then the total elapsed time is going to be equal to the end time minus the start time. And then we can print out the elapsed time. Okay, so let's go ahead and run this. And the elapsed time is in seconds. So this took 0.1798 seconds. Now, let's try this for func2. So we can try function 2 here, run this, and it looks like function 2 was slightly faster at 0.16. Now, there are definitely limitations here. For one thing, if the function is faster than 1/10 of a second, so let's go ahead and change this to just do this for the n is equal to 10, you'll notice elapsed time starts getting a really hard time trying to get that precise. So if we say now func2 is 10, you run that, func2 ran so fast, it's actually less than 1/10 of a second, so the elapsed time, its precision is actually not good enough. So if we change this to both just 1, and you run both of these, they essentially tell you the elapsed time was 0. So for very simple pieces of code or code that runs very fast, the precision may not be enough to actually even show anything on elapsed time. And you'll notice, even if it can show up on elapsed time by running, whoops, this one's still running quite fast. So for something like 10,000, let's try 10,000 here. I don't know if this will show. We'll run this. So for something like this, these are both running so fast, it becomes really hard to actually compare their performance and whether or not there's a true difference between function 2 and function 1. It does look like function 2 is performing faster, but it's really hard to tell from this how much faster it's performing. So what we're going to do is instead use the timeit module, which is specifically designed to time code. So again, this is a very simple method that you can use for larger blocks of code that are simpler and you just want to get some total elapsed seconds. But when you actually want to know down to the efficiency which one is taking less time, it's time to move on to the timeit module. Okay, so we will import timeit. In order to time our code with the timeit module, you'll notice we will call timeit.timeit. And if we do shift tab here, there's really three main things to look at. One is statement or STMT. Another is setup. And then there's number of times you actually want to run this code. Because timeit is going to run the statement code over and over and over again to figure out just how efficient it is. So what we need to do is get anything that needs to be set up beforehand, the code we actually want to test, and then the number of times we want to test it. What's a little interesting about this is that statement and setup are actually passed in as strings. You don't actually pass in the raw functions themselves. So let me show you what I mean by that. We're going to say statement is equal to, and then here I will have triple quotes in order to have a multi-line string. And my statement, which is the actual code I want to run, is going to be function1, and let's go ahead and just run it for the number 100. So recall, if I try to do this with the previous method by just typing in 100, it's most likely going to be too fast for me to actually figure out what the difference is between these. But with time it's going to run this over and over and over again and tell us which one is faster. So my statement is function1. Next is the setup. Same thing here. We're going to have triple quotes to have a multi-line string. And setup is essentially what code needs to be run before you call statement over and over again. And statement is calling function1, which means setup should have function1 defined. So statement is what you're going to be calling over and over again. Setup just gets called once in order to set everything up for the statement code. So for the statement code, I need to set up function1 in my setup, essentially defining it. So we'll come up here. I'm going to copy this, and then I'm going to paste it here in my setup. Note that the indentation is still there. So I have my statement, I have my setup. Now it's time to time my code by saying timeIt.timeIt, pass in my statement, pass in my setup, and we'll say the number of times I want to run this. We'll go ahead and run it 100,000 times. So 100, 1, 2, 3, 1,000 times. We run this, and this will take a little bit of time on your computer. Obviously, if you make this number larger, it will take more and more time. But what we really want to do is just run it enough times where we can see a discernible difference between the function calls. All right, so I can see here that this took 1.52 or 1.53-ish seconds to run this particular statement call 100,000 times. Let's do the same thing now, but for function 2. So again, triple quotes here. The statement I'm going to be running is function 2. We want to make sure that it's a fair comparison by also passing in 100, same as the previous statement. In fact, let's call this statement 2, just so we don't get confused. And then we'll call setup2 equal to, because we need to set up the code in statement 2. I'm going to scroll up here and say def func2. Go ahead and copy and paste that. There we go. Run that. And now we have statement 2 and setup2 ready to go. We'll go ahead and copy the code here. We want to make sure we run it the exact same number of times, otherwise it's not a fair comparison. And here I'm going to change this to statement 2 and setup2. Let's go ahead and run this. And you'll notice that function 2 does look to be performing faster. And if you want to get more clarity on this, you can go ahead and just run it more times. So in this case, I'm going to run this for 1,000,000 times, and I'll do the same thing for setup2. I'll run this 1,000,000 times. And now we can do a really fair comparison, because after running the same functions 1,000,000 times, you should know or have a discernible difference if one is much faster than the other. So you'll notice on my computer, and keep in mind, depending on your hardware, it may take longer, but it looks like function 1 took about 14 seconds to run 1,000,000 times. And function 2 took 11.3 seconds. So over and over again, we see that function 2 is in fact the more efficient function. And as you increase this number, that difference should become even more clear. All right. Finally, because timeIt is a built-in module of Python, Jupyter Notebook has actually a magic method, so to speak, which essentially calls timeIt within a cell. So the way this works is you have 2 percentage signs and then call timeIt, and this needs to be the first line in the cell. And then right below it, you call the function you want to test. And essentially what's nice about this is you don't need to provide any setup, because Jupyter Notebook will use the previous cells that you've already defined as setup. So now I'm just going to call function 1. Let's pass in 100 here, run it, and then I'll call the same thing, timeIt, and now for function 2, 100, and run this. And note what it reports back. It essentially, by default, We'll run this for 100,000 loops. So it's running this for 100,000 loops. And then it tells you the best of 3. It took 13.7 microseconds per loop. And then function 2, its best of 3 took 11.2 microseconds per loop. So here again, we're confirming that function 2 is running a bit faster. Okay, you can check out the documentation online for TimeIt module in the official Python docs for more information. Thanks, and I'll see you at the next lecture. Welcome back, everyone, to this lecture on unzipping and zipping files. A zip file is just a compressed file, meaning you can take a bunch of files and compress them to save space inside of a .zip file. What we're going to do here is learn how we can do this programmatically with Python. We will create a zip file, compress text files, and then insert them into the zip file, close it, and then we'll show you how to unzip the information back into a folder of your choosing. Let's get started. All right, here I am in the Jupyter Notebook. What I'm going to do is create a couple of text files for us to work with and compress. So the first method we're going to be showing you uses the zip file built into Python, and later on we'll show you how to do shell utilities to essentially archive an entire folder at once. But we'll start off by showing you how to zip individual files and compress them. But we'll first need to create those individual files. So I will say f is equal to open, let's say file1.txt, open it with mode W+, so we can write to it and create it. And then I'm going to say fwrite, and let's say one file, and then fclose. So there's our first text file, and if you're running this in the same directory I am and scroll down, you should see file1.txt there, and if we open it up, we can see one file. And let's do this one more time. I'm simply going to copy and paste the code and create a second file. So we will say file2.txt, and let's write what's in it as 2 file. So I have these two text files, confirm that right here, file2.txt, we're ready to go. So the next step is, let's say these were really large text files and I wanted to compress them because I want to send them in an email. And maybe I want to do this programmatically. Well, what I can do is import zip file. This is built into Python, and we can use it to compress files. Essentially, it creates a zip file, and then you can compress individual files and insert them into the zip file. The first thing you do is you actually create the zip file first. So I will say comp_file as my variable, which is just going to stand for compressed file. And the way we do this is we say zipfile dot zipfile. Notice the capitalized Z and F. Then you call whatever you want to call your .zip file. So we'll call it comp_file.zip. And we're going to write to it. So we basically have the mode equal to W. So there's our compressed file, and if you come back to the folder you're working with, you'll notice you actually have a zip file here. Now, this zip file is empty, so what I'm going to do is I'm going to compress these text files and then insert them into the zip file. So the way the zip file library works is you essentially take your compressed file and then you write to it. So you say, go ahead and let's grab file1.txt. And then the other thing you have to specify is the compression type you're going to use. And if you take a look at the library, the link online for the documentation will show you various compression methods, but the most standard one is zip deflated. So that means we're just going to say compress type is equal to zipfile.zip_deflated. And you should be able to use tab to autocomplete that. So what that has done is it's grabbed this text file, compressed it, and written it to this zip file. And this whole time, this zip file is still open to us inside of Jupyter. So Python has this zip file open and it's working with it. Let's do the exact same thing for the second file. So we'll say compfile.write, and I will grab file2.txt, and then same as before, we'll use the same compression method. So we will copy this and paste this here. And now, just like the first one, it's grabbed file2.txt, compressed it, and written it into the .zip file. So the .zip file now contains compressed versions of file1 and file2. Once you're done using that file, simply close it by saying compfile.close. Okay, so now we have out here this compfile.zip. It's no longer empty. It actually contains the compressed versions of file1 and file2. So what's the next step? Well, you're probably going to want to know how to extract the items from a zip file. To do this, we simply create a variable. So I will call this zip object. And you call the zip file library, call zip file again. Notice the capitalized Z and F. You point it to the zip file you're going to extract from. So in this case, it's compfile.zip. So this hopefully feels similar to open up a normal text file. And in this case, since we're extracting stuff from it, I just want to open it up in read method. Once you run that, you have two options. If you're looking for one specific file, you can call just the extract method. And here you basically have to say, I just want to extract, for instance, file1.txt. Or if you want to extract everything, probably the more likely case, you're just going to say extract all, and then you have to decide what the actual folder is going to be. So what path do you want to extract this to? So let's go ahead and call this extracted_content. Run that, and now what's happened is we've taken the contents of the zip file in read mode, and we've extracted them to a folder called extracted_content, which exists in the same location as this Jupyter notebook. And if you ever need to confirm what location you're at, just type pwd into a notebook. All right, so I come back up here. If you scroll up to the top, you should now see a folder called extracted content. Open it up, and now you see our extracted and decompressed versions of file1.txt and file2.txt. So you open those up, and here we can see one file, open up the other, and you should see two files. All right, so that is the built-in zip file library with Python. Now, keep in mind, typically when you're doing things like compressing folders and files, you often just compress an entire folder and extract an entire folder. You usually are not compressing single text items like this over and over again. So what we want to do is if we just want to archive an entire folder or extract an entire folder, usually the shell utility library is a better tool for that. So we've already played around a little bit with the shell utility library, which we can import as shutil. And what we can do here is essentially point out a directory that we want to turn into a zip file. Let's go ahead and turn this extracted content folder into a zip file. So what we're going to do is grab now an entire directory folder. So I'm going to say that my directory to zip, so we'll say dir to zip, and let's give it the file path to this, which is going to be this guy, this full path here as a string, except there's one more file, which is called extracted content. So what I'm doing, unlike before, where I had to individually add in these text files, I'm just going to say, you know what, go ahead and we're going to compress this entire archive, extracted content. So let's go ahead and do that. We know the directory we want to zip. Make sure your backslashes or forward slashes match up to what is written out in pwd. And then we're going to give an output file name. So we'll say output file name. Let's just say it's called example. And then we call shell utility dot make underscore archive. And this accepts the output file name. Essentially, where do you actually want to output this zipped version? And then the second parameter, you'll notice is called format. What format should it be in? It can be something like a zip file or a .tar file. So let's go ahead and choose zip file. And then the third thing we have to choose is the directory to zip. So what are we actually zipping? Which in this case was that extracted content folder. So we'll just say directory to zip. So we have to put in that whole file path there. Okay, so let's go ahead and run this. Notice now there exists an example.zip file. And if we come back up here, we should be able to scroll down and now see example.zip. So this is typically easier to use, the shell utilities, because it works with just an entire folder instead of having to do this one by one. So we were able to zip up an entire folder. Now the last thing we need to show you is how to actually extract the contents from a zip file with shell utilities. It's a very similar process. You simply call shell utilities, and instead of making an archive, you are now going to unpack an archive. And you'll notice here it takes the file name you wish to unpack, which is this zip file. So we'll go ahead and say example zip right here. Then the Next parameter is what should the extract directory call it. So let's call this final unzip. Essentially, it'll create a folder called file unzip. And then you have to say what actual file type is this. So it's a .zip file. So we pass in zip here. So that third parameter is format. We go ahead and run this. And now it's taken example.zip. If it's in a different file, you'll have to, or excuse me, different folder, you have to provide the full file path, but we're unpacking it. It's right here in this location. And if we come back up here, we should be able to scroll up and see final unzip. There's file 1.txt and file 2.txt. Okay, so usually you're probably going to be using shell utility. It's a lot simpler to use just with the make archive on an entire folder and the unpack archive on an entire folder. All right, that's it for this lecture. If you have any questions, feel free to post to the Q&A forums. I'll see you at the next lecture. Welcome everyone. It's time to test multiple skill sets that you just learned in the advanced module section of the course. In order to do that, we've set up a puzzle for you to solve. So let's go ahead and do a quick overview of the exercise puzzle notebook. And in the next lecture, we'll go over through an example solution. All right, here I am under Advanced Python Modules. If you scroll up, you should see numbered at 08 another folder called Advanced Python Module Exercise. And then if you open that up, you'll notice that there's a puzzle as well as the solutions. And then this zip file called unzip.me for instructions. Let me bring over the actual modules exercise puzzle notebook first. Okay. So for this puzzle, your goal is basically to solve and try to figure out what you need to do. So we're actually not going to give you too much guidance. Instead, basically figure out what you need to do. And your first clue is this zip file called unzip.me for instructions. So basically unzip it. There should be a text file there for you to open up with instructions, and then read the instructions and see if you can figure out what you need to do. Now, if you get stuck on where to start or what steps you should take, I did have a link here to a Google document that will give you step-by-step what you should be considering and what you should be doing. But I highly encourage you to basically try to figure it out on your own. Start by trying to unzip this file and then see where that takes you. Again, this is a puzzle, so really there's not that much guidance we've set up for you, but if you do need it, there is this guide hints link that you can click on. Okay, that's all I will say for now. If you end up getting stuck and this guide and hints don't help you, check out the next lecture where we go step by step through a possible solution. I'll see you there. Welcome back everyone. In this lecture, we're going to go through a solution for the Advanced Modules exercise puzzle. Let's get started. Okay, so here I am at the Jupyter Notebook. I've gone ahead and opened up a new untitled notebook in the same location as the exercise puzzle and exercise solutions. Since the first thing I need to do, step one, is to unzip this file. Let's go ahead and do that. I'll use the shell utility library. So I will import it, and then we'll simply use unpack archive. So you should be able to say shell utility, unpack archive, and then we need to tell it what actual location the zip file is in. Since I'm in the same folder, I just need to essentially pass in the zip file name. So in this case, I can simply say unzip.me for, and then I can tab autocomplete this. Now the second thing is where we actually want to extract it to. In my case, I'll just leave this as an empty string because I want to extract it at my current location. And then the format is zip. All right, that's step one. If you come over here, you should notice that there's extracted content. And if you open this up, you can now see we have 1, 2, 3, 4, 5, and then the instructions.txt. Also, as a quick note, extracted_content is the default file name that shell utility will provide for us. So we want to open up instructions.txt file. Technically, I can just click this open, but let's go ahead and open it with Python as a quick review. Lots of different ways you can do this. I'll use a with statement. So we'll say with open, and then inside of extracted content, I want to open the instructions.txt file. I'm just using tab to autocomplete there. We'll open it as f. Then we'll grab the content, say f.read, and we'll go ahead and print out that content. I could also just say print f.read. Okay, so step one, we unzip the file. Good job with that. We now see those 5 folders, and each of those has a lot of random.txt files. So if I take a look at one of these, such as 1, notice there's a ton of text files here. And if I open up one of these text files, it's essentially just a bunch of lorem ipsum text, just a bunch of Latin filler text. So what do we have to do here? Within one of these text files is a telephone number formatted like this. Okay, so we need to use the Python OS module and regular expressions to basically iterate through all of those text files, open it, and search for the telephone number. So let's go ahead and move on to step 3, where I will create a regular expression to find the link. So this is pretty similar to what we covered in the regular expression lecture. So I know that the pattern, if I were to look up in the table, there's different ways I could write this pattern, but I know that it should be a digit, 3 of them, then 3 more digits after the dash, another dash, and then 4 digits. Okay, so there's our pattern. If you're confused on this, you can review the regular expressions lecture series, but basically this says 3 digits, a dash, another set of 3 digits, a dash, and then a set of 4 digits. Now what I would always recommend doing is, before you just go ahead and use this pattern, is just test it on a single string to make sure it's returning what you expect. So I will say my test string is equal to, here is a phone number, and we'll say it's 123, 123, 1234. Okay, so there's our phone number. Let's go ahead and make sure that our pattern can find it. We can use find all for this. Pattern versus the test string. Run that, and it looks like it found the phone number. Perfect. Next, I'm going to make this into a function. And the function is going to accept a file, the text file. It's going to open it up and then search for the pattern within that file. So I will call this def search. It takes in the file, so I'm going to iterate through all those text files. And then the pattern is going to be what I defined up here. So we'll go ahead and copy this, paste it, and we'll first open up the file. So I'll say f is equal to open the file, and in this case I just want to read the file, so we'll say mode is equal to r, and we'll grab the text of the file by saying f.read. So now that I have this text, it should basically act like the test string I had here. And instead of using find all, I'll just go ahead and use search to search through this text. So I'll say if regular expression search pattern text, meaning it found it there, then I'm going to return the results. So I'll say return search pattern text. And technically there's lots of different ways you could do this and set up your function. Else I'm going to just return an empty string. So essentially what this is going to do is it's going to open up the file, look for a pattern there, and then if it finds it, it will return it. So we'll go ahead and create that search function. Now what I have to do is I have to walk through all the files here, essentially using the OS module, because I need to not just go through all the files in this folder, but I need to go through all the files in folders 1, 2, 3, 4, and 5. So this is too much for me to do manually, which means I will use the OS module for this. I will import OS. Let's make our results a list, and then I'll do the following. I will say for folder, subfolders, files in OS walk, and I'll say just go ahead and do this in the current directory plus extracted content. So we'll say os.get current working directory, and then concatenate it with the string extracted content. So in case you are interested in what this looks like, I'll show you right here above it. So I'm going to insert this, and so it's basically saying my full current location plus extracted content. Because recall, my untitled notebook is actually kind of sitting above this extracted content folder. So I want to go ahead and I'll provide that full file path. And now, what do we want to do? We'll go ahead and search through this. So put the colon in there and say for f in files, essentially all the text files. I actually don't care too much about marking down subfolders or folders for now. I just want to search every single text file. Then I will say the full path to this text file is equal to folder plus, in my case, 2 backslashes since I'm on Windows, maybe a / for you if you are on Mac OS or Linux, and then the file itself. So why do I need to do this? Well, Recall that I'm going to be calling this search function on each file. And what I want to do is make sure I don't get any file path errors. So in order to do that, what I'm going to do is call the folder that it happens to be in, and then the file itself as well. And if you're kind of confused on this as far as what this is actually doing, you could, if you want to, print out the full path, but you'll just get a bunch of print statements of every single file in there. But I only recommend doing that if you're still confused on what the full path actually looks like. And then we'll say search full path. All right, so pretty much very simple function here, but what are we actually doing? All we're doing is we're going to do a walk through that entire extracted content folder. I'm going to look at each file, grab its file path, and then I'm going to perform my search function, which is up here. Recall this is my custom search function, not regular expression search. And my search function takes in the file and essentially searches for the pattern in it. If it can find the pattern, it'll return back that telephone number. If not, it just returns back an empty string. Alternatively, I could also just say pass and not return anything. Okay, so we're going to run this. Should take a little bit of time. And then we'll say, what are my results looking like? So for R in results, in fact, if I just take a look at results, you'll notice it's essentially a really long list with a bunch of empty strings because I'm usually just returning an empty string. But somewhere in here, there's a telephone number. So here we have the actual match object. So what I'm going to do is say for R in results, if R is not equal to an empty string, go ahead and print out R and group it together to actually grab the whole match. So let's go ahead and run that. Okay, and there's the telephone number. So if you're wondering what this phone number actually does, I would encourage you to call it if you're in the United States, because as of this filming at least, and for the past 10 years pretty much, this telephone number has been a hotline where you can listen to a Hall & Oates song. And you can check out the lecture notebook for more information on it. The official number is called Call & Oates. Okay, so other adjustments you can make to this, if you wanted to, you could just say else here, pass. And then in this case, if you were to run this again, let's go ahead and make results an empty list. Run that again. Now results might be a little cleaner for you. So it's just going to be a bunch of nones. So there you can just search for an actual object there. Really up to you. There's tons of different ways you could do this. But the main thing you had to do is figure out that this was the number hidden within all those text documents. And there should just be one telephone number you return. I added some other digits within some other text files that were not formatted correctly, so you should really only get this single Call & Oates phone number. Okay, I hope you enjoyed that puzzle, and I will see you at the next section of the course.